Hello viewers, tutorial 9 question 5, and we're differentiating a variety of functions here, so we need to work out what approach we're going to take. We need to use the chain rule here because all of them feature a function inside a function. We have tan of 44 e to the x, so 44 e to the x is inside the tan function. It's not tan times 44 e to the x. It's not cot times x squared minus x over 10, and it's not log times cosec of x. They're all second function inside the first function. So that means that they're a job for the chain rule. So we need to say here that z is going to be 44 e to the x, and that leaves us with a equals tan of z. Okay, so we have dz by dx is 44 is a multiplying constant, so it stays there. E to the x differentiates to itself. And here we're differentiating a with respect to z. Tan differentiates to secant squared of z. So we are using the chain rule here. We don't have a y, we have a capital A instead, so dA by dx is what we want, is dA by dz times dz by dx. So dA by dz is sec squared of z times the 44 e to the x, which gives us 44 e to the x times sec squared of 44 e to the x. Okay, so that's question A done. Question B, we have z is going to be again what's inside that bracket. So z is going to be x squared minus x over 10, and that leaves us with b equals cotangent of z. Okay, so we need to differentiate both of these. So dz by dx is differentiate x squared, we get 2x, minus x over 10 is the same as 1 over 10 times x. Number times x just differentiates to number. And here we're differentiating to get dB by dz. So the derivative of cotangent is negative cosec squared. So we get negative cosec squared of z. And the chain rule tells us dB by dx is dB by dz times dz by dx, which is minus cosec squared of z multiplied by this derivative of the inside of the bracket, which is 2x minus 10, or 2x minus 1 over 10. And then we need to substitute our z back in, so we get 2x minus 1 over 10 cosec squared of z was x squared minus x over 10. Okay, question C, we have z as cosec, so z is going to be cosec of x, and then we have C equals ln of z. So dz by dx is the derivative of cosec, which if we differentiate cosec, we get negative cotangent times cosec. And if we differentiate c, we get dc by dz equals, differentiate ln, you get 1 over z. Okay, so we want, chain rule tells us dz by dx is dc by dz times dz by dx. So what's dc by dz? That's 1 over z times minus cosec of x times cotangent of x. So we get minus cosec of x times cotangent of x, all of that over z, but z is cosec. So we get negative, cosecs are going to cancel, So this is going to be negative cot of x. Okay, thanks for watching. Over and out.